We have now question number 2. What question number 2 says, it's a complete each of these sentence. Number 1, the part A, a mass, a mass given as 57 grams to the nearest kilogram is between dash kg and so I've written there is a mistake. Let's correct. This is not a gram. This is kg. So dash kg. Here we also have to find the lower bound and upper bounds. So the solution for this is we first the accuracy is 1 kg because of this one nearest kilogram, which define the accuracy is 1 kg and the error term is 1 divided by 2 is 0.5 kg. So the upper bound for this is UB, its original value plus the error term. So original value is 57 grams plus the error term, which is 0.5 kg. So you will get 57.5 kg. So this is our upper bound. So now the lower bound is original value minus the error term, which is 57 minus 0.50, so we will get 56.50 grams. So this is our upper bound and the lower bound. So we have completed this, the question is complete. So is between 56.50 and 57.50. So but in a book it will always explain this like this. It will say this is a 57 and this is 58 and this is our 56, and the lower bound is on the left side, this which is 56.50, and the upper bound is 57.50. So this was our final answer. So we have a question number 2. Question number 2, part E. So part E says we have a mass given as 0.6 0.634 kg to the nearest gram is between dash kg and the dash grams. So a mass given is 0.634 kg to the nearest gram is between dash kg and dash kg. So we have now the accuracy is in grams. No? So the difficult part is what is to convert this question as to the accuracy here is in a gram. So we will convert this kg into the grams. No? So first convert the unit. Step number one is to convert the unit. So 1 kg is 1000 grams. So 0.634 into 1000, you will get 634 grams. So now we converted into the grams. So step number two, what is accuracy? So it says to the nearest gram. So the nearest gram, what does this mean? No? So our accuracy here is 1 gram. So the error term is like error 1 gram divided by 2, you will get 0.50 grams. So now this is the error term. No? So first we have to find the lower bound and then the upper bound, but now in the last we will convert these grams into kg because the required answer is in a kg. So while finding the upper bound, its original value plus the error term. What is the original value? Is 634 grams plus 0.5. So in the last you will get 634.5 grams. Lower bound, what is the lower bound here? Is original value minus the error term. So the original value is 634 grams minus 0.5, you will get 633.55 grams. So but we want our answer in a kg. So convert this into a kg. 634.5 divided by 1000, you will get 0.6345. And while converting this 633.5, so you will get 0. So this is like a 633.5 divided by 1000, you will convert this into a 0.633 and 5. This is in a grams. So this is grams. So the Lower bound is 633 6 point 633 and 5 kg. Sorry, let me. There should be a kg. So this is not a correct term. Let me correct it. So this is in a kg. So 0.634 kg. So we have a question number 3. Now, same exercise. This is exercise number 10.1. But the question is different. We have a drain cleaner. Uses a pole made up of 10 identical flexible pieces. Each piece is 1 meter long. Each piece is 1 meter long. Measured to the nearest centimeter. What length of a of drain cleaner? What length of a drain uh, can be showed that the drain cleaner could reach? Can you be sure that the drain cleaner could reach? So what the question says here, let's do the solution. A drain cleaner uses a pole made up of 10 identical flexible pieces. So we have a 10 identical flexible pieces. So the one piece is 1 meter long. If a one piece is 1 meter long, so 10 pieces will become 1 into 10. So this will become a 10 meter long. So, but the now we have the accuracy is given into a um, nearest centimeter. So first of all, let's find the how many meters will become for the 10 identical flexible pieces. So how long will be 10 identical flexible pieces will become. So, so this is simple. So one is 1 meter long. So 1 into 10. So this is 10 meter long. So while converting into a centimeter, so 10 into 100. So we have a question number 3. Drain cleaner uses a pole made up of 10 identical flexible pieces. Each piece is 1 meter long, measured to the nearest centimeter. So we have a pole, and basically it's like this kind of a pole, and these are the some kind of a 10 flexible pieces to rub the floor type, no? So we have this one flexible piece, talking about this one flexible piece. So we have the piece, each piece is a 1 meter long. So just pick the one piece, no, from this. So here the solution for this is the given is a 1 meter long. Each piece is the 1 meter long. So we will pick just a one piece. So this is the 1 meter long. So the measure to the nearest centimeter. So now we have accuracy is in a centimeter. So first we will convert this 1 meter into a uh, step number one is to convert this 1 meter long into a step number one is to change the unit for this now. So 1 into 100, you will get 100 centimeter. So now 1 meter, each piece is a 100 centimeter of long. But the step number two, now we have given the accuracy here, no? So the accuracy is nearest centimeter. So this is the 1 centimeter. So the error term is 1 divided by 2, and you will get to 0.5 centimeter. So this is our error term. So what length of a drain can be showed that the drain cleaner could reach? So now the length of a drain cleaner, so it is like some kind of we have a pole, and this is some kind of a one flexible piece. So we are not calculating this complete, but just this part. So now you will add this with the error term, 0.5. So this the upper bound for this will become 100 plus 0.5, and you will get 10.5 centimeter. So this is our original term plus the error term. So you will get 100.5 centimeter. So now the lower bound for this is, so 100 centimeter minus 0.5, you will get 99.5 centimeter. So the upper bound, what will become the upper bound here, no? Into the meters, no? So now we are converting into the into meters. So 100 minus 5 divided by 100, you will get 1.005 meters, and the lower bound will become 99.5 divided by 100, you will get 0.005 Let me see. 0.9995 meters. So this is our lower bound, but in a meters, and this is our upper bound, which is in a meters. So the length of it could reach in between this, no? So you can, the length can be reached 0.995 less than 1.005 meters. So now we have a question number 4. What question number 4 says, first see what it says now. Question number 4 says, we have question number 4. It says a rectangle a rectangle measure 12 centimeter by 5 centimeter. So the length is 12 centimeter, and the width is 5 centimeter. But what it says in a question number 4, it says with both measurement, both measurements correct to the nearest centimeter. Number A, work out the greatest possible parameter of the rectangle. So we have a rectangle, it's like this. So this is the 12 centimeter length, and this is the width, this is the 5 centimeter. But the accuracy now here given is the nearest centimeter. But it says find the greatest possible parameter. For finding the greatest possible parameter, you first find the greatest possible length and the greatest possible width. So the formula, first of all, the formula is for the perimeter is equals to 2 into length plus 2 into width. So here you can see correct to the nearest centimeter. So now the accuracy term here is 1 centimeter. So the error is 1 divided by 2. You will get 0.5 centimeter. So this is our error term. So for the finding the greatest possible parameter, you will find the greatest possible length or the upper bound of a length. So it is like a 2 into upper bound of L is for the length plus 2 into upper bound for the width. So for upper bound of the length, it is like a 2 into its length 12 plus 0.5 and plus 2 into width 5 plus 0.5. So for the finding the upper bound, we will add the error term. You will get 2 into 12.5 plus 2 into 5.5, and in the last what we will get while using the calculator, we found the length is 36 centimeter. So this is 36 centimeter. So now the part B, it says, what it says, work out the smallest possible area of the rectangle. Work out the smallest possible area of rectangle. So first of all, what is the area of a rectangle? No? So area is the length into width. So for the smallest possible area finding, it's like a lower bound of a length into lower bound of a width. So the lower bound of a length is like a, here it lower bound is 12 minus 0.5. So this is our original value and this is our error, into the width is our here is 5 minus 0.5. So we will get here 11.5 into 4.5. So while finding this, it's 4.5 into 11.5. You will get 51.75. It's in a centimeter square. So it's in a centimeter square. So this is the length of the smallest possible area of a rectangle. This is the smallest possible area of a rectangle. Now we next we have some more part of this. So now we have sums and differences of a variable.